At the beginning of our report, we wanted to check on the overall trends of the different pollutants over the selected time period. Since the pollutants were measured using different units, namely micrograms per cubic meter and milligrams per cubic meter, we decided to create two separate plots placed next to each other in order to visualize the trends more meaningfully. In addition, the plot is interactive. By clicking the play button, the animation starts and allows us to observe how the trends evolve over time. We also aimed to make the visualization as inclusive as possible, so we used a colorblind friendly color scheme. Overall, we can mainly observe that pollutant levels either remained relatively constant or decreased over time.
For question 2A, we explored which areas of Madrid experienced the highest and lowest nitrogen dioxide pollution levels. We combined a hotspot map with a ranked bar chart. The map shows spatial distribution of pollution across Madrid, and we see on average, higher nitrogen dioxide concentrations are found in the center of Madrid, while farther from the center, it shows lower pollution levels. And the bar chart complements the map by ranking stations from highest to lowest, and that's also based on average nitrogen dioxide concentrations. We have this timeline slider that moves from 2001 to 2018 with our beautiful interactive map. And we can see how both hotspot locations and station rankings change over time. Since they update together, it allows us to compare trends across different years.
With this chart, we aim to identify areas that have gotten more or less polluted between 2008 and 2018. For this sake, we compare the trends in pollutants between 2008 and 2018. We realized that there were cyclic behavior each year where there's an increased phase, a peak, and then a decreased phase. So for most of the air stations and for the whole of the city of Madrid, we can see that the trends are consistent years in and years out. So there is no much increase or decrease patterns for most of the areas. But for the areas for example, for Plaza del Carmen or Villaverde, we can see that in later years, there is an increase in air concentration in nitrogen monoxide. We presented nitrogen monoxide here because it has most of the measurement between 2008 and 2018 for most of the stations. And these patterns are also observed in different pollutants. For instance, carbon monoxide, which has similar patterns. Thank you.
Similarly to question 1, we were also interested in the relative changes in the pollutant levels. Here we used the measurements from 2001 as the baseline and examined how the different pollutants changed over time. Lines above the 100% baseline indicate that the concentration of a given pollutant increased compared to 2001, while lines below the dashed line indicate that the concentration decreased relative to 2001. Overall, the plot mainly shows decreasing trends, with only one or two pollutants exhibiting an increase compared to the baseline year.
When looking at the different pollutants, we also wanted to see how they relate to each other. That's why we have plotted a correlation matrix from the data aggregated by year from 2001 to 2018. This is a colorblind friendly graph, meaning that the yellower a cell, the stronger the correlation, and the bluer, the weaker. On the diagonals, we can see ones, meaning that each of the pollutants are perfectly correlated with themselves. And from this graph, we can also see that most of the pollutants are positively correlated with each other. One exception to this rule being ozone, which is negatively correlated to the other pollutants.
For question 4, we expand our analysis to explore the consistency of pollution hotspots across Madrid over time. This visualization builds on the map from question 2A, and it allows the user to use a dropdown to switch between different pollutants. So if we move through the timeline, we see a very similar pattern where we have higher concentration on average in the center and lower concentration outside of the center. But some pollutants have little to no data, and that can make it difficult to be reliable and harder to compare over time. But if we go and look at the marker size and colors represent the average concentration that was measured. The larger and darker the marker, the higher the pollution intensity. And as we see, when we hover over a hotspot, it provides detailed information, pollution, station name, concentration, etc. So both the timeline and the dropdown makes it easier for the user to explore how the hotspots emerge and change over time.